All right. Hi, Olivia. We've already started today. We've talked about sine, cosine, and tangent, and how those represent, comparing two sides of a triangle. So ultimately, guys, we'll get into more of this as chapter goes along, but sine, cosine, tangent is trigonometry. Trigonometry is the math behind and the comparing angles and side lengths of a triangle. Okay, so if I want to find the sine of this angle, let's just call this 30 degrees. Okay, that's going to be the opposite side, which is this side, over the hypotenuse. Okay, so we're comparing two sides. So the sine, cosine, and tangent are all ratios of two sides. Okay, we'll get into that in example one. Now, ones that we don't see so much of are cosecant, secant, and cotangent. Let me get to the right page here in my book. Whoop. Okay, so cosecant is just the opposite of sine. So the cosecant is going to be the hypotenuse over the opposite. Secant is the hypotenuse I always forget my E on hypotenuse. Over the adjacent. And then cotangent is the adjacent over the opposite. Questions there? Okay. So example one, I've got this triangle, and on your drawing, I believe we have 5 here.
7.
Oh, 7.
But that was just an angle.
7. 24 and 25, is that right? All right, and let's call this angle A and this angle B. Okay, and this is a 90 degree. So our directions say to find the sine, the cosine, and the tangent values of A and B in the right triangle. Okay, so I'm going to find the sine of A, cosine of A, and the tangent of A. Okay, so with respect to A, this angle, I want to find the sine of A. Sine is which two sides? Opposite over hypotenuse. So the sine of A is going to be 7 over 25. Do 7 divided by 25 on our calculator. Let's round to 4 decimal places. It's just 0.28. Perfect. Okay, so the sine value of this angle A that we don't know is 7 over 25, which is 0.28. All right? The cosine value of A, cosine is which two sides? Adjacent hypotenuse. This is going to be 24 over 25.
0.96.
0.96. Okay, and tangent A is the opposite. 7 over the adjacent 7 over 24, which is 0.2917. If we round to 4 decimal places. Questions there? Oop, I forgot to do B over here. Let's do sine of B. Why don't you do these on your own, please? Cosine B and tangent B. Okay, so sine of B, here's B now. So my opposite side is 24 now, and my adjacent is 25. So again, that's going to be 0.96.
You mean hypotenuse, right?
Or hypotenuse, what did I say?
You said adjacent.
Sorry, opposite over hypotenuse. Cosine B is going to be the adjacent over the hypotenuse, 7 over 25, which is 0.28. And then our tangent is going to be the opposite over the adjacent, so 24 over 7, which is going to equal
3.4286.
3 point what?
4286.
4286. Questions there? Okay, next box. Cofunctions. Okay, cofunctions. If we go up here, what do we notice about sine of A and cosine B?
They're the same.
They're the same thing, right? So what do we know about angle A and angle B?
They equal 90.
They equal 90, right? Because we have a 90-degree angle, so I know that angle A and angle B have to be 90. So we know that angle A and angle B add up to 90 degrees. So sine of A is going to be equal to the cosine of 90 degrees minus our angle A. Now, if you think about that, that makes, if I go back up to this example, that makes sense. Because we said sine A was 0.28. Well, cosine of 90 minus A, that would give us whatever that angle is, B. So cosine B is the same thing. So sine A is equal to cosine of 90 minus A. Okay? And cosine of A is going to equal the sine of 90 minus A.
Freaking had these all nice and organized.
Okay? Secant and cosecant go together. So secant is going to be, of A, is going to be cosecant of 90 degrees minus A. And cosecant is going to be secant of 90 degrees minus A. And lastly, tangent is going to be cotangent of 90 degrees minus A. So cotangent of A equals cosine of 90 minus A. And cotangent is going to equal, cotangent, my fault, is going to equal tangent of 90 minus A. Okay, now don't get these confused. If I go back up to my first chart here, sine and cosecant are reciprocals of each other. Okay? Cosine and secant are reciprocals of each other. And then tangent and cotangent. How do I remember that? Because in my mind, it makes more sense for sine and secant to go together.
Agreed.
And cosine and cosecant to go together, but I know it's vice versa. So that's how I remember, okay? Now, in cofunctions, it's a little bit different. Sine and cosine go together. Secant and cosecant go together. And then tangent and cotangent go together. So, example 2. It says, write a function in terms of its cofunction. So what's the cofunction of cosine?
Cosecant. Cosecant.
Well, look at our chart. With cosine, what goes with cosine?
Wait.
Sine. Don't say sin.
Wait, up here though, which ones go together? Cosecant and sine.
Okay, so I'm not looking at the top thing.
I know, but what did you just explain before those?
At the top, I have sine, cosine, and tangent. We're okay with those. Now, what are cosecant, secant, and tangent? Well, they are the reciprocals of all of them.
Mm-hmm.
So cosecant goes with sine as far as being reciprocals of each other.
And then down here,
Down there, it's different
cosecant goes with
secant.
secant. All right.
Follow me there?
That's
So I am working with this chart right now. So what is the cofunction of sine? Cosine.
Sine.
It's sine, right? So I know that the cosine of 52 degrees is going to be the same thing as the sine of 90 minus 52. What is that? 38. So cosine 58 is the same as 52, is the same as sine 38. Okay? What's the cofunction of tangent? So I know cotangent, tangent 71 is going to be the same as cotangent of 90 minus 71, which is cotangent of 19. And the cofunction of secant is cosecant. So this is going to be cosecant of 90 minus 24, which is cosecant of 66.
Yeah, no, I'm not excited.
Questions there?
How about you, Liv, huh? I just had to give one.
Olivia, are you excited about this backside?
Yeah.
You do sound a lot like Olivia.
Okay, so solving equations, this is pretty easy. If you look here, I have cosine of something equals the sine of something.
Why are those things in the
Well,
zeros?
okay, these are thetas. Theta is a member of the Greek alphabet, or a letter of the Greek alphabet. It just means x. But usually those represent angle measures. So this little thing, theta, it just means x. It's an unknown value that we're trying to find. But it usually refers to an angle. Okay? So just imagine that they're x. All right? Now, we just learned that cosine of something is always equal to the sine of its complement, right? Complement from last class means 90 degrees, right? So I know if these truly are equal, because they are cofunctions, what do I know about theta plus 4 and 3 theta plus 2?
They're going to equal 90.
They've got to be 90. Since they're set equal and since these are cofunctions. So I can say theta plus 4 needs to equal 3 theta plus 2.
So now I think you should probably minus 2 and then add theta.
I want to get all my thetas on one side. How about I get them all to the left? So I'm going to minus theta on both sides. Again, we're just treating it like an
All right,
x.
minus theta, my bad.
So I get 4 equals 2 theta plus 2. Minus 2 on both sides. So I get 2 equals 2 theta. Oops, not cube. Oh, I'm back. I messed all this up. What did you say, Jace?
I said, well, I said add theta, but I meant minus it.
No, before that. You said, and I don't know why I
Minus
said this. I said this. Go back.
I said it equals 90.
It equals 90.
It,
So why did I set them equal to each other? I have no idea. I'm ready for the weekend.
Same.
They're equal 90.
oh, I see.
Jace said it, and I said yes, and then I went and set them equal to each other. So let me backtrack. Since these are cofunctions, and that they're equal, I know that this and this has to be 90. They've got to be complements of each other. Now this is a little bit better. So when I do this, I'll get 4 theta plus 6 equals 90, minus 6 on both sides. I get 4 theta equals 86, excuse me, 84, and theta equals
21.
21 degrees.
Anybody remember that video?
Yeah.
Okay? So we're looking at this one. Cotangent and tangent are co-functions of each other. So same exact thing. I know that 2 theta minus 18 needs to equal, excuse me, add plus theta plus 18 needs to equal 90. Add them together, I'll get 3 theta. Those go away, don't they? It's nice. And I don't know why I put Q. 3 theta. Divide both sides by 3. And theta equals 30 degrees. Questions there? Okay, now to the good stuff. We're going to fill this chart out, and this chart will help us, okay? This chart will help us in our homework, okay? So this might take a little bit, but it'll help us in the long run. Now, what I want to look at, we see 30, 45, and 60. Those are just common angles that we come across in talking about trigonometry. So what I want to look at is I want to look at all the values, sine, cosine, tangent, cosecant, secant, and cotangent of those 3 angle measures, okay? So if I had a 30-degree angle, okay, and let's call this 1. Okay, and let's call this let's back up. I'm going to do it differently. Let's start with an equilateral triangle.
Really?
2, 2, and 2. We're all going to call them 2.
Wait.
What's our angle measures on all these?
30, 30, 30.
If it's equilateral.
Should be 30 degrees.
Jason, what are you doing? Put your phone away.
Right. That's like a sign, a rap group I follow. It's
60.
like they got a whole thing about it.
What's each angle measure, guys?
60.
It's 60. Why 60, Logan?
The triangle itself has to equal 180.
It's got to be 180 degrees. So 60, 60, 60. Now, here's what I want to do. I want to split this guy in half.
Still gonna equal
So now, what's this?
1.
That's 1, and that's 1.
Mm-hmm.
So what's this side?
Wall 1. Just a guess.
So this is 1, this is 2, and this
1.5.
is... We don't know it.
Really?
Now, can I do the Pythagorean theorem to find it?
Yeah.
Absolutely, I can do the Pythagorean theorem to find it. So let's do that. So 1 squared plus x squared equals 2. Here we go, do this with me. 1 squared plus x squared equals 2 squared. 1 squared is 1 plus x squared equals 2 squared is 4. I can minus 1 on both sides. X squared equals 3. square root both sides. And so x is going to equal the square root of 3. So the height of this particular thing is the square root of 3. So this is 30 degrees, and this is 60 degrees. Would you guys agree there? Okay. So using this, let's fill out some of this chart. So if I look at the sine of 30.
Okay.
Sine of 30. Sine is which two sides again?
Opposite and hypotenuse.
Great. Opposite and the hypotenuse.
First.
So opposite of 30 degrees, because we're doing 30, is what? 1, and the hypotenuse is 2. So the sine of 30 degrees is always going to be 1/2. In your calculators, hit sine 30. Enter.
Where's that?
2.5. Wow, amazing.
Oh, they're right here.
Should we just do it with our calc?
Okay, we'll talk about that. Now, let's go to cosine of 30. Because cosine of 30 is which two sides?
Square root 3 over 2.
It's the square root of 3 over 2. The adjacent over the hypotenuse. So it's the square root of 3 divided by 2.
Oh, so this comes back down to the
Unit circle.
yeah, unit circle.
Okay? Now, Jason's question. Can we just do this on our calculator? No, because if you do cosine 30, do it. What do you get, Mia?
0.8663254.
Some ugly number, right? We want exact values. I don't want some ugly number. It just so happens that sine 30 works out nice and neat.
I don't wonder the fraction thing.
All right? Now, tangent. Tangent of 30 degrees. Tangent is opposite over the adjacent. So that's going to be 1 over the square root of 3. Now, going down here. 1 over the square root of 3. Math people are weird. There's a weird rule that says, hey, we don't want square roots in our denominator. Who remembers how to get rid of the square root in the denominator? Logan?
Both the top and the bottom of square root 3.
Absolutely. I can multiply the top and the bottom by the square root of 3. Because when I have a fraction, I can multiply that fraction. Let's say I don't write this down, but if I have 2/3, I can multiply that top and the bottom of that fraction by a number. Let's just say 7, and I get 14 over 21. That value is the same as that value. It's just not necessarily in the simplest form. Well, in this case, we don't consider this simplest form because it has a square in the denominator. Now, in the numerator, I have 1 times the square root of 3. That's a square root of 3.
Over
3.
9.
Square root of 9 is
3.
3. So here's our rule of thumb, guys. If you take a square root times a square root, you just get that number. So, tangent of 30 is the square root of 3 over 3. Square root of 3 over 3.
Wow. Trig has got to be my least favorite.
Other questions there? Now, cosecant is the reciprocal of what?
Sine.
Sine. So what's the reciprocal of 1/2?
2.
2. So cosecant of 30 is 2. Secant is the reciprocal of cosine. But when I flip square root of 3 over 2, what happens?
You got to multiply it by square root.
Oh, goodness. Now, let's go down here a little bit. I get 2 over the square root of 3. Well, let's get that out of there. Multiply the top and bottom by the square root of 3. So this is going to get me 3. So 2 square root of 3 over 3.
These are not good memories, Mr. Cole.
So 2 square root of 3 over 3 is secant theta.
What's that line?
Just me hitting there. Okay, and then lastly, cotangent, we need to reciprocate tangent. So this becomes 3 over the square root of 3, right?
It is, yeah.
And then multiply by the square root of 3 in the top and the bottom. In the numerator, it becomes 3 square root of 3. And in the denominator, it becomes 3.
Threes canceled, don't they?
Oh yeah, those cancel, right? So cotangent is just of 30 degrees is the square root of 3.
Classic.
So, what have we done? We have found the exact values of the cosine of 30 degrees. Sine, 30 degrees. Tangent, 30 degrees, and so on. We found the exact values. Okay? Now, let's go down to 60 degrees. Because I think I have 60 degrees here, right? So, sine of 60. Sine is what?
Opposite over hypotenuse.
The opposite side over the hypotenuse, which is the square root of 3 over 2. Whoa, don't I have the square root of 3 over 2 somewhere? Oop, I'm in the wrong spot there, sorry. Square root of 3 over 2. Did we already learn that? That the sine of one angle is going to be equal to the sine of its complement, right? 60 and 30 add up to 90 degrees, so those are going to be the same. What do we think cosine of 60 is going to be? Half. Let's go check it out. So cosine of 60 is the adjacent side, which is 1, over the hypotenuse 2. 1/2. Okay, let's go tangent. Tangent of 60. 60 is right here. Tangent's what?
That would be adjacent,
Opposite over adjacent, so it's going to be square root of 3. What's the cofunction of tangent? Cotangent. Check it out. Bingo, bango, bungo. Tangent and cotangent. So tangent of 60 is the same as cotangent of 30. Okay? So cosecant is what? Is the reciprocal of sine. Cosecant is the reciprocal of sine, so I need to reciprocate this. Did we already reciprocate that?
Yeah.
When we did the reciprocal of square root of 3 over 2 up here, it was 2 square root of 3 over 3. So this is going to be 2 square root of 3 over 3. Secant of 60 is the reciprocal of no, that's cofunction. Reciprocal
Of sine, right?
of sine. So I need to go, excuse me, no, cosine. Cosine.
Cosine.
So I need to reciprocate 1/2 to get 2. And then cotangent is the reciprocal of tangent. So
So square root of 3.
it's 1 over the square root of 3, right? Isn't that the reciprocal of tangent?
Yep.
So then we need to multiply by the square root of 3 on the top and the bottom.
Yep.
This gets me the square root of 3 over 3. How we doing out there? Struggling, I can tell. Last thing, 45 degrees.
I feel like I should remember more of these from the unit circle.
Probably. "45 degrees in a right triangle. If this is 45, what's this?
45.
Aren't they both 45? Okay. Now, what about these two sides?
They're the same.
Why?
Because the
Because-
angles are the same.
Yes, because the angles are the same. So this angle is 45 degrees, so that means this side has a particular length. This side is 45 degrees, so that means this side has a particular length. So they are going to be the same. Okay? So I'm going to call this 1 and that 1. For this example. It doesn't matter. I could have called it 3 if I wanted to. Okay? I called it 1. What's our hypotenuse? Well, Pythagorean theorem. 1 squared plus 1 squared equals x squared. So this gets me 1 plus 1 equals x squared. 1 plus 1 is 2 equals x squared. So that means x is going to equal the square root of 2. So the hypotenuse of this triangle is the square root of 2. So, let's look at this angle. Sine of 45 degrees right here. Sine is the opposite over the hypotenuse. 1 over the square root of 2. We don't like the square root of 2 in our denominator, do we? Do we? No. So we're going to multiply by the top and the bottom by square root of 2. So here I'm going to get the square root of 2 over 2. It's going to take a while for me to go back and forth. So the sine is the square root of 2 over 2. Cosine is the which two sides, Mia?
Adjacent over hypotenuse.
The adjacent over hypotenuse, so it's 1 over the square root of 2. Oh, what's it going to be?
It's all the same.
Same thing. So cosine 45 degrees is the square root of 2 over 2. Tangent. Tangent of 45 is opposite over adjacent,
Which we,
which, look at our picture. I'm not going to scroll down because it takes me a while to...
2 over 2, isn't it?
1.
Okay, I lied. I'll go down to my picture.
Where's the square root of 2? Square root of 2.
Opposite over adjacent, which is 1 over 1. So 1. Cosecant is the reciprocal of what?
Sine.
Sine. So we need to reciprocate square root of 2 over 2. So it's going to be 2 over the square root of 2. Multiply by the square root of 2 on the top and the bottom. So in the numerator I get 2 square root of 2. And in the denominator I get 2. So what happens?
2's cancel out.
2's cancel out and I get the square root of 2. So secant is the reciprocal of cosine. Well, the cosine and sine are the same, so what's this going to be? Square root of 2. And cotangent is the reciprocal of tangent, so this is going to be 1. Okay, now, why do we do this? Today in our homework, at towards the end, we're going to have to evaluate, hey, sine of 45 degrees. Well, now we can just look it up in our chart. Okay? What are we leading this to? Eventually, down the line, I don't know exactly when, we will derive or come up with the unit circle. All right? Which you use in its entirety in trig. Okay? So we will get to the unit circle, but by doing this, we already know most of it.